You might have heard about ones and zeros.
Are you a 1 or a 0?
You've been staring at a computer screen way too long, homie. Life's not that binary.
And at some level, you can form an idea about how computers work, and that it's just, well, a bunch of ones and zeros. But what exactly does this mean? In this video, that is exactly what we will cover, and we will do it as simple and as clear as possible. Hi, welcome to the series Computers Are Not Magic. I'm Ghost, and today we are understanding binary. Okay, so simply put, computers are just electricity. But of course you know that. I mean, we plug them into wall outlets, we charge them up, it uses electricity. But it's the way that electricity runs through them and makes them work and behave the way we expect them to. Think about something extremely simple like a light switch. Electricity flows, the light turns on. Electricity stops, the light turns off. That's it. Now, imagine instead of one light switch, you had a bunch of them lined up on a wall. Each light switch can only be in one of two positions, on or off. Computers work in a very similar way, except instead of large switches on a wall, they have billions of microscopic electrical switches inside the hardware. When electricity flows through a switch, we call that a 1. When electricity does not flow, we call that a 0. That is binary. Binary simply means a system with two possible states, on or off, 1 or 0. But here's something really important to understand. By itself, a bunch of on and off switches means absolutely nothing. Imagine walking into a room and you see 4 light switches on the wall. Some are up, some are down. You wouldn't automatically know what that pattern means. Maybe it controls lights, maybe it controls machines. The switches themselves are just switches. Computers work the same way. The computer is simply turning electricity on or off. We are the ones who decide what those patterns mean. To better understand, let's take a look at a small example. The goal is to represent the number 3 in computer code. Remember this. Imagine we have 4 switches. Right now they look like this: 0, 0, 1, 1. 0 means off, 1 means on. Now here is where we give those switches meaning. In binary, every set of switch positions represents a value that doubles each step, reading right to left. To clarify that, let's create labels at each position to help guide us. Starting with the first position, the far right, we will label this 1 since it's our very first position. Next, the one to the left, we will label as 2 since all we're doing is doubling. The next one is where it becomes even more noticeable that we are doubling because guess what it is? It's 4. Lastly, we will label the last position as 8 because once again, we double at each position, and since the previous position was 4, we just added 4 and arrived at 8. Simple mathematics. Now, let's look closely at our switches and associate them with the labels we just made. Positions 1 and 2 are the only ones that are on, so we simply take the labels and add them together, which give us 3. 2 plus 1 equals 3. And that's it. We gave this pattern a meaning, and that meaning is the number 3. But remember, and this is important, the computer is not thinking that this is the number 3. The computer is simply just toggling switches. We, humans, created the rule that says when the switches look like this pattern, we will interpret that as the number 3. Another helpful way to think about binary and its positions is as containers. Each container can only fit one value and accepts only a 1 or a 0. Because each container only has 2 possible options, we call this base 2. In normal math, we use base 10 because each digit can hold 10 values ranging from 0 to 9. But with computers, each position can only hold 2, so the range is 0 and a 1. Hopefully this is an aha moment on the infamous zeros and ones. So anyways, back to our container example. The technical term for a container is called bit, which is short for binary digit. So a bit can only hold one value at a time, and those options are what? A 1 or a 0. When we start combining multiple bits together, we can represent larger numbers. For example, 8 bits means 8 tiny containers that each can be on or off. And if you look at the bits with their labels, remember each bit starts from the right and doubles as you move to the left. We see how quickly the values increase and the possible numbers just 8 bits can represent in binary. imagine with even more bits. But numbers are only the beginning. Those numbers can represent other things. We just have to give it meaning. Think letters, sounds, programs, images. For example, computers use something called character encoding, which is basically just a big rule book that says that this number here represents this letter. In one common system called ASCII, the number 65 represents the letter A. And because computers store numbers in binary, that letter is actually stored as a pattern of switches that look like this: 0, 1, 0, 0, 0, 0, 0, 1. Again, nothing magical is happening. Those are simply just electrical switches. Some of them are on, while the rest are off. We decided that the pattern represents the number 65, and in ASCII, 65 represents the letter A. This is the big idea behind binary. Computers only understand electricity flowing or not flowing. Everything else we give meaning to. Everything inside your computer, text, pictures, videos, programs, all comes down to patterns of bits. And those bits are nothing more than electricity turning on and off extremely fast. So when people say computers are just a bunch of ones and zeros, what they really mean is that they are machines that control electricity in very specific patterns. Once we give those patterns meaning, electricity becomes numbers. Numbers becomes letters. Letters become entire software. And suddenly, something that looks like magic is just a bunch of tiny electrical switches turning on and off a billion times per second. And that is the foundation of binary. If you found this video interesting, learned something new, or further cemented the idea that you already had about computers, consider giving it a like. And if you haven't already, consider subscribing. This video is a part of the series Computers Are Not Magic, and it just happens to be the very first video. And with that, I am Ghost, and I'll see you in the next video.